Hello, today we are going to cover 11.3, probability of multiple events. You guys will be able to find the probability of an event A and B, as well as the event A or B. Believe it or not, those two little words make a big difference. When the occurrence of one event affects how a second event can occur, the events are dependent events. That just means the first event affects the second event. Otherwise, the events are independent events. So are the outcomes of each trial dependent or independent events? And then explain. Basically, does one event affect another event? So we are going to have part A, roll a number cube, then spin a spinner. If you're going to roll a number cube, then spin a spinner, the events don't affect each other. One thing, they can happen simultaneously, and it's not going to change the outcomes of each other. So this means this is independent. Example B, pick one flashcard, then another from a stack of 30 flashcards. Now, if you had 30 flashcards, we're going to do a smaller group here. I'm going to do 5 or something. If I pick this one out, and then I just pick another, I have changed my grouping. I now have 29 flashcards if you visualize more than just 5 drawn out. That means this is a dependent event because I don't replace this one and I have to draw a different one. It does affect the second event. So we'll write that out. Picking the first flashcard affects the possible outcome of the second card. So this means this is a dependent event. And then example 3, select a coin at random from your pocket, replace the coin and select again. So say you have 3 coins in your pocket, you take this coin out, but then you put it back, you still have all 3 coins, meaning because the first coin gets replaced, it is an independent event. All right, and then we have probability of A and B. If A and B are independent events, then the probability of A and B, that's how you say this, probability of A and B, can be found by taking the probability of A times the probability of B. So in example 1, at a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. What is the probability that you get a regular drink and regular chips? So notice this word "and" here. That means we are going to do the probability of A and B. So we have the number of regular drinks over the total number of drinks. And then we also have the number of chips that are regular over the total number of chips. So the number of regular drinks is 5, and the total number of drinks is 15. The number of chips that are regular is 12 over the total number, which is 20. Now to find the probability of A and B, I should say, you simply multiply these two. Now, if you forget how to multiply fractions, you just multiply straight across. 5 times 12 is 60. 15 times 20 is 300. And then you can go ahead and reduce this. This actually just reduces to 1/5. Or you could say 0.2 Or you could say this was a 20% probability that you would get regular drink and regular chips. Okay? Now, two events that cannot happen at the same time are called mutually exclusive events. So if A and B are mutually exclusive, then the probability of these guys together is equal to 0. So you roll a standard number cube. Are the events mutually exclusive? Explain. So you roll an even number and roll a prime number. So we have number cube 1, 2, 3, 4, 5, 6. Highlight our evens. And then 2 actually happens to be prime. So this is not mutually exclusive. This is kind of a confusing vocab term, just because it's kind of like a double negative. Okay? Because 2 is prime and even, these events can happen at the same time. Okay, so if the events can happen at the same time, they're not mutually exclusive. If the events cannot happen at the same time, they are mutually exclusive. So, little confusion with like double negative idea, but that's just how it works. So our next example, rolling an even number and rolling a number less than 2. So we have 1 through 6 again. I really like to visualize these. So we have even numbers, and we need a number strictly less than 2. Well, the only number that is less than 2 is 1. So because these events do not overlap, they cannot occur at the same time. This is mutually exclusive. We can say there is no even number less than 2 in the rule of a number cube. Okay, now we're going to move into the probability of A or B. So we've been discussing A and B. Now A or B changes it up. To find the probability of either event A or event B occurring, you need to determine whether events A and B are mutually exclusive. So, P of A or B, we have an equation, P of A. So the probability of A plus the probability of B minus the probability of A and B. Now if we look back up here, we know that if A and B are mutually exclusive events, then the probability of A and B is equal to 0. So this would just be a 0 here. But if they are not mutually exclusive, then that is actually something that we have to subtract out. So in our first example here, if A and B are mutually, we do have one more thing. If A and B are mutually exclusive events, then the probability of A or B, just as we were saying, is just P of A plus probability of B. Now we have another example. At your high school, a student can take one foreign language each term. About 37% of students take Spanish, about 15% of students take French, about 9% of students take Mandarin Chinese. So, part A, what is the probability that a student chosen at random is taking Spanish or French? So we need the probability of Spanish or French. Now this is just equal to the probability of Spanish plus the probability of French. Now they actually gave it to us as a percentage, so I'm going to switch those to decimals just so I can work with them easier. Honestly, I'm glad they gave it to us this way because then we don't have to work with fractions. So if you take the probability of Spanish plus the probability of French, then we have 52% or 0.52 of students take Spanish or French. Now the reason why I did not do this probability of A and B subtracted from that is because it says students can take one foreign language each term. This means that these are mutually exclusive events. They can't take both classes at the same time. They can only take one or the other. Same thing on this next one was the probability that a student chosen at random is taking Spanish, French, or Mandarin Chinese. So we have the probability of Spanish or French or Mandarin. So we go ahead, take the probability of Spanish, once again switch this to a decimal, 30.37, plus the probability of French, 0.15, plus the probability of Mandarin Chinese, 0.09. That actually equals 0.61, or 61% of students take those 3 foreign languages. Once again, they are mutually exclusive, so they cannot take more than one class at a time, meaning we don't need to subtract out the probability of P and B. Probability of A and B. And then part C, without knowing the number of students in the school, can you determine which language most students take? And I would say yes. The percent of students tells which language is chosen by more students. And in this case, because Spanish comes in at 39%, Spanish is chosen the most. Okay, so now we're going to look at ones when they are not mutually exclusive. So when two events are not mutually exclusive, we do have to subtract the probability of the common outcomes in our P of A or B. So we have to go back and use this top formula, okay? So example 1, we are going to suppose you reach into the dish and select a token at random. What is the probability that the token is round or green? So we need probability of round or green. So we need probability of round plus the probability of green minus the probability of round and green, because as you'll see, sometimes round and green does happen at the same time. So the probability of round, we have 1, 2, 3, 4, 5 round objects out of 9 total ones if you count them. We have the probability of green. You'll see there are 3 green objects. And actually, round and green happens twice, so you need to subtract 2 over 9 from that total. We end up getting, when you add and then subtract these fractions, 8/9 minus 2/9. So we end up getting 6/9, which we can subtract to 2/3. All right, so the probability of round and green is round or green, not round and green. Round or green is 2 out of 3. Now, example 2, suppose you select a token at random from the dish. What is the probability square or red? We work through it the same way. Probability of square or red. So we need the probability of square plus the probability of red minus the probability of square and red. Okay, so go back to our picture. Probability of square is 1, 2, 3 out of 9 still. Probability of red is 1, 2, 3 out of 9. And then we have one shape that is both red and square, so we need to subtract 1/9. So after you work through the fractions, we end up getting 5/9 is the probability of square or red. Okay, and last example, we have suppose you select a token at random from the dish above. What is the probability that the token is green or square? So probability of green or square. So we have the probability of green plus the probability of square minus the probability of green and square. You'll notice we're just doing the same thing over and over with different combinations here. So the probability of green is 3 out of 9 once again. I think we already did that one. We also already did square. There are 3 out of 9 square objects. And there is only one green square, so we subtract 1 out of 9 from there. And we also end up getting 5/9 for this one. So although we were finding the probability of two different things, we ended up getting the same probability. All right. That is the end of today's lesson. Have a great afternoon.